Hello and welcome back to my Code with Me for FTC. And today we're going to be going through a hardware class. We're going to make the base class and then we're going to implement it. So what we're first going to do is create a new team code file. And we're just going to go a new Java class. We're going to call it hardware config. And the main point of this class, as we've learned in previous videos, is just to make it so it is able to keep all of our stuff consolidated. So we don't get super into like the nitty-gritties and like we have to have 5 different classes that all initiate the same motors and same servos and all that kind of stuff. So what we're first going to do is we're going to make our constructors. So we're going to go public hardware config, and then we'll put in anything we actually need in here. So we're going to put in a linear op mode, and you'll see why later. We'll also put in a hardware map, HW, and then that should be it. Okay, so now we just got to make the rest of our methods. So the next method we're going to make is the init robot method. And basically what this is going to do is we're going to set all of our variables inside the class to what we need them to be set to, essentially. So inside our hardware config, we're going to want to have a linear op mode, and we're just going to call that op mode, set it to null, and then we're also going to want a telemetry, and I will just let that import itself. Let's see, what else do we need? That actually should be it. So in init robot, we're going to take that hardware map as a parameter. We're also going to take that op mode as a parameter, and we're just going to kind of set all this up in here. So when we do this, we're just saying, okay, hey, op mode up here, we're going to be set to that OM right here, and then we get the telemetry right there. So next, what we can do in here is we can add a motor. So if we were to add a motor, as you can remember before, we go DC motor test, that works just fine, is equal to null, and then we go motor test is equal to hardware.dcmotor.getMotorTest. So that's pretty easy there. Next, what we have to do is just set the direction. We'll just set it to forward for now because I don't actually have a robot to test all this on. And then let's see. Let's also initialize an elapsed time object. So as you can remember before, we just go elapsed time, and then we'll just go runtime is equal to new elapsed time. And we'll set runtime.reset down here. So that's going to reset it as soon as we initialize the robot. Next step here, we're just going to call that init robot. And bada bing, bada boom, we're done there. So essentially, if you wanted to add more to here, you easily could. Just add it in here. So like in future videos when we add subsystems, it's going to be in here. And also, just adding anything that needs to happen. So if you need to set your motor differently, you need to set anything else up in a different way, do that here because it will reflect it everywhere else. So next, what I like to do is I like to make a build telemetry. So we'll go public void build telemetry. And essentially what this is going to do is it's going to allow us to just say, okay, yeah, here's all the data we have, let's send it. So then we can send it at any point in time. So we have those two things added. We can also add something like, oh hey, let's add something from the gamepad. Telemetry.add data, and we're going to add gamepad down. And we'll go op mode.gamepad1.down. There we go. Okay. And the reason we have to do this op mode dot is because our hardware config class does not have any object gamepad. So if I just start typing gamepad1, I'm not going to get anything because we physically cannot use that. But if I start typing op mode, or in a different file, of course, op mode.gamepad1, well, look at that, it's right there. So next, what I usually like to do is go public void main, and this is going to be the main script that you're going to write. And honestly, usually what I tend to do is just go do bulk, because that's where we're actually going to control the entire robot. So now what we can do here is add mechanism code. What else do we need to do? We need to be able to control that test motor. What else should we do here? Right here we would control any subsystems. And then finally, power all the motors and all that kind of stuff. And then the last thing, we build that telemetry. And then all that's going to do is just, hey, we're going to run this. We're just going to run exactly this. That's at the very end, we just run that. Let's see, what else are we going to do here? Actually, that's about it. So I'll go ahead and implement all this real quick because I have all the stuff on the other side. So I'm going to just add this, and this is all going to be using my library. So when I paste this, it's going to have a lot of errors, but it should be able to import them, or not. So I'll just leave that there as, hey, this is what we're going to do. You can implement any way you want to do this. So like for instance, for mechanism, we could have a double for every value. So front left is equal to, let's just say 0 right now. You could have that for everything right there. And then what you do is at the end, when it's powered motors, you go motor test.setPower. Just so we know we're not setting power differently throughout the entire loop. And that'll cause a lot of bugs that prevent you from making it work correctly. Alright, and then I'll show this a little bit more in the next video. But once this is all written out, it's actually going to do everything the robot needs to do. So next what we're going to do is we're going to add a new teleop, and this is using my linter bundle, which is a plugin on the Android marketplace. So I'm just going to hit new teleop. We're going to call this teleop 1. So now what we're going to do is we're going to write this class out. So we're going to go hardware config robot is equal to new hardware config with our linear op mode, which is this, and then the hardware map, which is just hardware map, semicolon, we're good. Yeah, so we actually need to move this here. It's my bad there. And then what we're gonna do is just go robot.knitRobot. And actually, you might have caught that there, but this should not be possible. So we actually want this one to be private because this initialization already happens here. So if you try and call that initRobot, it's gonna double it up. So right there, we've used it one time, we're all good to go there. We can delete this line fully. Okay, so next thing what we're gonna do, and actually the better way to do this is just to go hardware config robots is equal to null, just so we know we have that value there, and then later we can go robot is equal to hardware config of this, and that's it. Next, all we need to do is go robot.doBulk, and we're done. That's our whole teleop. You do not need to do anything else for this. Because do bulk, let's see, what does it do? It drives mechanism, it controls our test motor, controls any subsystems, it powers those motors, and then finally it just builds that telemetry. So we're all good to go there. That's basically how that hardware config works. And then now let's add a auto config class. Okay, so this one's a little bit different because we're actually going to extend the hardware config class. And what we're going to do here is we're just going to extend this class fully. So what this does is it just says, okay, we're going to make a hardware config with this op mode and hardware map. And then what we're going to do is we're just going to add our own methods. So let's add a Boolean tracking is equal to false. Let's see. What else? We could add a state. So integer state is equal to 0. We could add a start time. We could add current time. We can add elapsed time. All that kind of stuff. So these are the things that are going to be the auto specific. So for instance, in the past, I've had it as like pretty much all of my auto stuff is in auto config. And then all I have to do is just hit, okay, yeah, I want my auto config instead of my hardware config. And then it has all the separate methods. So what we can do here is we can go void init auto. And then, of course, we'll have to put it in here. And then let's just add a void move forward. And we'll just set this to super dot motor test dot set power. Let's see. Set power. There we go. Okay. So what this is going to do is it's going to access our superclass, which is hardware config, which already has been initialized. And then we're going to access that motor test variable, and we're going to set the power. So obviously you'll have to experiment and go where you want to with this, but we're just going to create a new autonomous here, and we're just going to go auto 1. And then, let's see, all we got to do is we just got to go auto config robot is equal to null. And then in here, we got robot is equal to new auto config. And now you can see that the robot dot current time is there. So we're good there. And actually we can see that if we add a hardware config robot 2 is equal to null, and then initialize that, let's see, is equal to 0. We'll just set that so it stops giving an error. Robot 2 dot current time does not exist because it only exists in our auto config. So then the way you would operate this is just inside here, go robot dot move forward 0.5. And obviously you'd have to add your own methods, but it's pretty simple to control now because we have these functions, and we can just go robot dot move forward of 1, and we can do all these different things. We can do robot dot turn. It's not implemented, but we could do that theoretically. So yeah, that's how hardware configs and auto configs work and help in the process of code development for FTC.